Before we can make the leap from arithmetic to algebra, there are a few concepts that are critical to understand. These concepts are variables, order of operations, and mathematics as a language. This video discusses order of operations. The order of operations is a definition that ensures consistency when performing arithmetic operations. That is the word I am trying to emphasize in this video: consistency. The reason the order of operations exists is to ensure consistency, specifically when chaining arithmetic operations together. Let's remove all knowledge of algebra for a moment and reduce all of our current understanding of mathematics down to just the natural form of counting: 1, 2, 3, 4, and so on, and the four common arithmetic patterns: addition, subtraction, multiplication, and division. Someone skilled with these tools might recognize that there's a possibility to chain operations together. To see the connection, we need to slow down a bit and recognize a few things first. Let's start with addition and subtraction. Consider the ways we add or subtract two numbers to get 12. For addition, 12 has 13 solutions. However, subtraction has an infinite number of solutions. Notice that with addition, we can swap the order of the numbers on either side of the sign, and it doesn't change the result. This means we only need to list 7 of the 13 proposed solutions to include all unique solutions. This doesn't work with subtraction. When we try to swap the order, we have a decision to make, and it highlights a few paths we could take to ensure consistency. If we were creating math on our own, we would need to decide what to do with this scenario. One possible solution is to say it's impossible to have anything less than nothing. However, this means for any subtraction problem where the number on the left is larger than the number on the right, we get 0 as the answer. If this was the height of our understanding of numbers, it would work reasonably well. However, saying that 4 minus 5 is the same as 7 minus 9 feels weird. There are a few other options to consider. We could restrict the order so the larger number is always on the left of the minus sign. This means we no longer have cut-off amounts when performing calculations. Again, if this was at the height of our understanding, it would work better than previous scenario, but it's still not quite what we need. The solution we have accepted in modern-day mathematics is the creation of a new type of number, numbers less than 0, called negative numbers. The existence of these numbers allow us to reframe subtraction as it relates to addition. This ensures we get consistent results. Redefine subtraction as adding a negative. Negative meaning a number less than 0. It's still counting backwards, just offers a new application. This means 23 plus negative 4 is starting at 23 and counting by negative numbers, counting backwards. Similarly, negative 23 plus negative 4 is starting at negative 23 and counting backwards, going further negative. With this simple change, we can now combine addition and subtraction into one consistent chain of operations. Just remember that a subtraction sign is no longer indicating subtraction, the operation, it's now indicating negative number. Multiplication can be defined as repeated addition. 2 times 4, for example, is adding 4 to itself 2 times. 4 plus 4. We could say add 2 to itself 4 times, which is 2 plus 2 plus 2 plus 2. This definition is a little more robust than skip counting definition I used earlier. It gets us closer to chaining multiplication and addition because it reframes multiplication as it relates to addition. This definition is also why it makes sense to perform multiplication before we do addition, because multiplication is really just repeated addition. In essence, convert everything to addition first, then condense it down to a single number. This works well with the redefined definition of subtraction too. Because subtraction is now a negative number, the multiplication operation is just repeatedly adding the negative number x times. The only ambiguity we need to clear up is what happens when we multiply two or more negative numbers. Remember, consistency is the main consideration. To ensure consistent behavior, we simply define what it does. A negative times a negative is a positive. An even number of negatives means positive, and an odd number of negatives means negative. I do not think it is common practice in math class today to specify that this is a choice and is not derived from some other concept. Thus far in our math journey of this course, everything has been the result of an underlying pattern or concept. This definition, negative times a negative is a positive, is nothing more than a required definition for consistent behavior. Humanity defined the relationship for consistency's sake. There is something unsatisfying about the need of this definition. Unfortunately, at this level of math, it is the best that we have. The clearest explanation I've heard of what multiplying a negative does is it reverses the counting direction. Imagine you are standing on the actual number line, and you are looking off in the distance. Multiplying by a negative means you turn around, and then you multiply by a negative again, and you turn around. Division is the only operation left to ensure that we can chain all four of the common operations. Like subtraction, we created a new set of numbers called rational numbers, also known as fractions. Instead of dividing, we redefine the term to ensure consistency within the order of operations. The chosen definition in modern mathematics, division is multiplying by a fraction. With everything reframed, we can now chain operations together. The order in which operations are executed is a matter of breaking everything down to its addition components. Division is multiplying by a fraction, so we do multiplication before we divide. Multiplication is repeatedly adding, so we divide before we add. Subtraction is adding a negative, so we add before we subtract. By the time we subtract, we have converted all operations down to an addition level. All that's left is to count. This is what ensures consistency in our chained calculations. If it's easier to memorize PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, go with that approach. However, I wish someone had explained the order of operations like this to me when I was learning them. The order of operations is all about ensuring consistent behavior when chaining arithmetic operations together. That's its whole purpose. It can be summarized by the process of reducing all numbers to their additional components before combining.